Good morning, class. Good morning, everyone. And how are you all doing now? Boys and girls sleeping or what? Watching some other channel or something else? Hello. Good morning, everyone. So gone. Am I the only one who is there in the class? Good morning. Good morning, everyone. That's better. That's better like my class. Very good morning. A very, very good morning to all of you. Okay, chalo. We'll begin. We don't have time, and again, as usual, the syllabus will be big enough. So let me tell you, the syllabus. This time will be photoelectric effect, black body radiation, and hydrogen spectrum. These three topics are there. Okay. Okay. So prepare hard. Let's begin with the spectra. Na? So please write down hydrogen spectrum, na? Or like say simply first spectrum. Simply first spectrum. And like spectrum, we have got two types initially to divide. Okay, one will be continuous, other will be discontinuous. Discontinuous. Okay. So when I say continuous spectrum, it like seems like say rainbow, which you see that, and that is coming from like say sun when the sun is diffracted. Okay. So over here, it's not that tough. So you will find all the colors like say Vibgyor. And all the colors, one and other will begin. And there is no discontinuity. There is no discontinuity. There is single band as such, without any discontinuity. While in the discontinuous spectrum, we have got two types. One is line spectrum. One is line spectrum. And second one is band spectrum. Band spectrum. Okay, band spectrum. So in the line spectrum, you will clearly see the distinct lines, separated by, distance can be irregular as well. But in the band spectrum, you will find out like say very thin lines which are closely spaced, forming band. You will not be able to distinguish these things from far. You will need a microscope to distinguish between the lines, the space between the lines. Similarly, something like this. So this is the band spectrum and this is the line spectrum kind of thing, okay? And they are called fingerprints of the atoms and molecules, which I'll discuss in a short while. So this is the basically a broad division of spectrum into continuous spectrum and discontinuous spectrum. Okay, so let us move forward now and we'll divide it further. So since I've done it, I'm doing the discontinuous spectrum. Discontinuous spectrum is line spectrum and band spectrum. Band spectrum. Are you getting it? So just learn certain things that line spectrum is shown by atoms. Okay? And this is shown by molecules or solid metals So when I'm saying the molecules or solid metals, I'm looking for kind of bonding. Some kind of bonding must be there. This bonding can be like say covalent bonding, or can be metallic bonding, Are you getting that? But when I'm talking about the atoms, I'm looking for individual atoms. For example, I can have helium atom, I can have nitrogen atom, I can have oxygen atom, maybe I can have sodium atom. So sodium atom, when I say sodium atom, this is only possible in what? Vapors. In the form of vapors. So when you vaporize the sodium metal, it will become individual atom in form of vapors. But if I'm looking for the band spectrum, remember that examples will be any molecule. It can be N2, it can be O2. These are atoms, these are molecules. I can have like say CO2, I can have NH3, any molecule which has any kind of bonding, and here it is covalent bonding. One more example can be like say sodium solid. So in sodium solid, we don't have individual sodium atom. We have got metallic bonding. The cations of sodium are there and the electrons are floating around. Okay. in the sea of, cations are out there in the sea of electrons. Sodium solid, or you can say iron solid. Are you getting that? All of you, come on. The difference between sodium atom and sodium solid. Here it is like, say, having metallic bonding, and here we are having no bonding out there. They are individual atoms. Okay? इधर देखो बन्नी साहब, इधर फोकस करो. कहाँ तुम फंसे हो यार? कैसे होगा तुम्हारा सिलेक्शन? Okay, done. Okay, now one more thing. This line spectrum shown by atoms is due to vibration of electrons, while this is due to vibration, or you can say rotation, or any movement, any acceleration of atoms in molecule. So the one question which is very famous question they ask you is that which among the following will show the band spectrum? I'm giving you option which will show band spectrum. So first option is like, say, helium, we can have sodium atom, and we can have like, say, CO2 molecule, we can have like, say, or we can say neon. We can say neon. Come on. Which will show band spectrum? Come on. Band spectrum is shown by metallic solids or molecules. Will be given by CO2. Very good. CO2. Very good. Excellent. Very good. Chalo. Like there is one more division left for the spectrum, and this time the spectrum will be emission spectrum, and this will be like, say, absorption spectrum. Important, very, very important, boys and girls. Come on, see that. So like, say, let's say we are having orbit number n1 and orbit number n2, where orbit number n2 is more than orbit number n1. The value of n2 is more than value of n1. Now, if an electron jumps from higher orbit to lower orbit, I told you, whenever electron jumps, accelerates, revolves, whatever it does, any kind of acceleration, it will emit what? It will emit electromagnetic radiation. It will lose energy in the form of electromagnetic radiation. For example, yes, EMR. Very, very good. Very good. This is, say, photon. And any photon is an example of electromagnetic radiation. Yes or no? And suppose this energy level is, say, En1. This is, say, En2. So the energy of this photon will be like, say, delta E. The difference between the energy of orbit number n2 and orbit number n1 will be equal to what? En2 minus En1. Agree or not? All of you, will you agree or not? Okay, then this delta E I'm talking about, this delta E will be equal to h nu. This nu is what? The frequency of the electromagnetic radiation, equal to what? Hc upon lambda. Are you getting or not? Very good. That means whenever an electron jumps, and if the energy difference is supposed to delta E, that delta E is the energy of the photon, the electromagnetic radiation, which is equal to h nu. Nu is the frequency of the photon, lambda is the wavelength of the photon or the electromagnetic radiation. Agree? Good one. Very good. Excellently good. Chalo, theek hai. Now, boys, what I'm saying is that if this electron jumps and this photon I'm saying is of, suppose, say, red color. Is suppose, say, red color, boys. Okay? Oh, and girls also. Now, same arrangement, same N1, same N2, and this time electron jumps from orbit number N1 to orbit number N2, where N2 is more than N1. Hello? So it will not jump by itself. It needs something. So it will need energy. It will need energy in the form of photon again. This photon, this is En1, this is En2. Boys, will you agree that this energy will be again delta E, will be En2 minus En1? Same orbits I'm talking about. Same, very good. So this photon will be absorbed by this electron and will drink the glucon D of red color and will move up. Agree or not? This energy difference belongs to red color. So this photon should also be what? Red color. Yes or no? This delta E will be again h nu equal to what? Hc upon lambda. This lambda and this frequency again belongs to red color photon. Yes or no? Now, listen to me. Over here, the electron jumps and emit red color. So on the screen, you will see red color. On the screen, you will see red color. But over here, you are shining a white light which contains all that colors, Vibgyor. So which color will be absorbed? Which color will be drunk by this electron? Red color? Red color will be drunk, yes or no? That means others will pass out. Others will go and join the screen. They will be reflected on the screen, but not only one color will not be there. Which color will not be there? Red color will not be there. Yes or no? Good one, very good. Now suppose say I am having like say 3 orbits are here. Same orbits out here. Now this is like electron jumps and it emits a photon. This is of say boys and girls red color, and here it emits a photon of say maybe we can say blue color. Now tell me bachcho, over here which color you will observe on the screen? Red, blue or others? Which color will be observed in this case? Jaldi jaldi, be quick. Twarga. Arey nahi Sharanya. You will see, arey nahi, in this case, if they jump here, you will see only red and blue. Only 2 photons are given. You will see red and blue. If electron jumps from here to here, it will emit a photon of red color, and from here to here, it will emit the photon of blue color. So you will see red and blue here. Yes or no? But if electron jumps from here to here and from here to here, this is the first case, this is the second case. In the first case, which photon will be absorbed? In this case, which photon will be absorbed? Red will be absorbed. Very good. Arey, red will be absorbed. This energy belongs to red color. This energy belongs to red color. Each color has an energy, na beta? E equal to h nu or hc upon lambda. Achha, and which photon will be absorbed here? Which photon will be absorbed here? I believe blue color. I believe blue color will be absorbed. So when you throw white light onto this arrangement, these electrons, they will drink red photon and they will drink blue photon and they will jump accordingly. Now, which colors will not be there on the screen? Red and blue will not be there, but others will be there. Hello? So over here, in this Vibgyor, remember that, you will see what? You will see red color. You will see red color and you will see blue color also. And this will be darkness. There will be no other color. And over here, if you look at that, if you see that Vibgyor, when the white light is passing, only red will be absorbed, blue will be absorbed, but you will see what? Violet and indigo, green, yellow and all that. You will see, yes or no? But not blue and red. They are absorbed. Yes or no? Be quick. So over here, you are throwing red and blue light. Here you are absorbing red and blue light. So red and blue light will not reach the screen. Can I say the colors you will see in the emission spectrum, the colors you will see in the emission spectrum are the colors which will be absent in the absorption spectrum. In the absorption spectrum. Yes or no? Yes or no? Agree? See, Madhu, but please focus over here. What I'm saying, that each color has a energy. Each color has energy. Madhu, listen to me. Like if I have got, like say I told you, we are having gamma rays, X rays, ultraviolet, visible rays, we are having infrared rays, we are having micro and radio. So as you keep on going from left to right, the frequency decrease and lambda increase. And we know that E is equal to h nu is equal to hc upon lambda. So that means energy is proportional to frequency is proportional to 1 upon lambda. So if frequency is higher, energy is also higher. That means I know that each color has a frequency. So over here, we have got Vibgyor. We have got Vibgyor. So as I go from left to right, the frequency decreases, which means what? Energy also decreases. So red color photon have a certain energy. Green has a certain energy. And now violet has a certain energy. So that's what I'm saying over here. This energy gap is of, suppose say, red photon. This gap is of blue photon. So when the electron jumps, it will lose energy corresponding to red and blue color. So you will see what? Red and blue color. Got it, beta? ठीक है यार, इतना टाइम होता नहीं अपने पास में ना. Emission. I mean, so can I say that the colors you will see in the emission spectrum will be the colors absent in the absorption spectrum, because one emits colors and one absorbs the same colors. So those colors will not reach the screen. Very good. And I mean, you can see that they both colors, these both spectrums can be what? Discontinuous spectrum as well. So emission spectrum will be formed when the electron fall from higher to lower orbit, and they will form when they go from lower to higher orbit. They are both photographic negative. The colors you will see here will be absent out there. That's the basic difference between the emission and the absorption spectrum. Now, yeah, correct. They are complementary. Very good. Shrinu. Correct. Acha, idhar dekho bachcho. I'm asking one question. Electron in which orbit will not show emission spectrum. First is second orbit, first orbit, third, fourth orbit, and fourth, seventh orbit. In which orbit electron will not show emission spectrum? Come on. Answer is first or what? First orbit. I mean, you are giving what? Name the orbit. Acha, name the orbit. Yes. If the electron is in the first orbit, in the first orbit, it cannot fall down. It cannot come down. First orbit is the ground state. Yes or no? It can come from the higher orbits. But not from the first. From the first, it can only jump. Up. I can jump from the ground. Yes or no? Very good. Okay, now let's do one more question. Not question. I mean, the next topic is hydrogen spectrum. Write down hydrogen spectrum, and we'll do it very quickly. Please pay attention, bachcho. Please pay attention the way you're doing it. Hai na? Keep it up. So out here, what I'm saying, over here, I'm assuming that this is a nucleus of hydrogen atom, and we are having certain orbits. Be careful. And suppose this is orbit number infinity. Now tell you one thing. How many electrons are there in an hydrogen atom? How many electrons are there in hydrogen atom? One electron is there. Okay, very good. Acha, how many orbits are possible? In hydrogen atom? Be quick. How many orbits? Everyone. How many orbits are possible? No. The answer is not one. Infinite orbits are possible. Infinite orbits. No, not one orbit. Infinite orbits. See that? Now, which orbit the electron will live will depend on the energy you are giving to the electron. For example, I'm saying that this is the first orbit, second, third, fourth, fifth, sixth, and till infinity. If electron has the least energy, it will live on the first orbit, first, second, third, fourth, fifth, sixth, and so on till infinity. You give more energy, it will jump there and will live there. You give more energy, it will further go up, even more, again, and more, and over there also. So which orbit the electron will live will be depending on its energy. More the energy of the electron, higher it will live in terms of orbits. Agree or not now? One electron is there, no doubt, but in which orbit it can live? Oh, it can live anywhere. It can live anywhere. Are you getting it or not? So like suppose say you are single. So in which city you can live? In which city you can live? You can live anywhere. You can live anywhere depending on the amount of money you have got. You have got lesser money, you will live in a small town. You got more money, you will go to Switzerland, you will go to like say Paris, you will go to Manhattan. Yes or no? Depending on the amount of money you have got. Hey, money means energy. Okay, bachcho? So is that concept clear? Though there is only one electron, but where it will live, in which orbit it will live, will depend on the energy given to it. More energy, higher orbit. Even more, or more. Gone. Anywhere. So these orbits are nothing but the energy levels. These orbits are nothing but energy levels. More the energy, more the energy level. Less energy, lesser the energy level. Hello? So for example, if I am an electron, you can see my energy. I will be living in a very high energy orbit. Very high energy orbit. And you people, you will live in the very low energy orbit. Agree or not? Okay. No, it's not like that. I mean, you are also energetic. That's the different thing, that we are not able to communicate that way. But nevertheless, we are doing a good communication, bachcho. Hai na? Chalo, aa jao. So over here, what I'm saying, now, anything which goes up will come down. जो ऊपर गया है उसको नीचे आना ही होगा, है ना? न्यूटन बाबा कह गए तो. So once you give anything energy, it will reach to the maximum height and will come down. So suppose electron is given energy, so it can be anywhere. But if it comes down and comes down directly to orbit number 1, it will emit photons. Which will belong to Lyman series. Which will belong to what? Lyman series. Are you getting that? And Lyman series belong to what? Which region? Ultraviolet region. They belong to ultraviolet region. And one question they also ask is that which among all the series we'll discuss, which is having highest energy. So this is the energy level which is highest. They have the highest energy. Ultraviolet rays are of highest energy level if we compare the hydrogen atom. Okay. Now, if electron goes anywhere, but it falls directly to orbit number 2. It will form Balmer series. Yes or no? Yes. And this lies in visible region. Very good. Visible region. But bachcho, remember that a very, very important question, that not all lines in the Balmer series are visible. I'll tell you one thing. How many lines are possible in the Lyman series? Come on, be quick, everyone. Dun-dun-dun. Be quick. Twarga. Jaldi karo re. और Lyman series में there are infinite lines possible. Electron can jump from anywhere. Like 1 to anywhere it can live. So if there are infinite orbit possible, they can jump in infinite ways also. Yes or no? Very good. Acha, how many lines are possible? In Balmer series? How many lines? Infinity again. Infinite lines are possible. Electron can jump from infinite orbits to orbit number 2. Again infinity. Very, very good. Supremely good. But out of these infinite lines in hydrogen spectrum, I emphasize hydrogen spectrum, only 4 lines are visible. Only 4 lines are visible. Rest are ultraviolet lines. Rest are ultraviolet lines. Okay? Yes or no? Dick chick. जल्दी लिख रहे यार. Okay. अच्छा इधर आओ. Now look up over here. And if electron is anywhere but falls to orbit number 3 directly, I mean these will be called Paschen lines. And they belong to near infrared region. They belong to what? Near infrared region. Similarly, if electron jumps from anywhere directly to orbit number 4, they will form bracket series. And they will be called infrared region. Similarly, we have if directly to orbit number 5 from anywhere, they will form fund series, and they'll be called far infrared. Very good. And then we have got, like, say, one more series, and that will be if it jumps directly to orbit number 6 will be called Humphrey series, and this is also far infrared. But don't get affected by, they all belong to one region that is called infrared region. Collectively they all belong to, and each series can have infinite lines. So when I say infinite lines, it means they are throwing infinite photons of infinite types of energies. Yes or no? Good. Very, very good. Excellently good. Okay. Now look. For, say, Lyman series, N1 and N2. N1 is the lower orbit and N2 is the higher orbit. N2 is more than N1. So for Lyman series, N1 will be what? Orbit number 1. And this has to fall from orbit number N2. Like, what are the possible values of N2? Come on. It can be 2, 3, 4, 5 and so on till infinity. Any other higher orbit. Okay, very good, brilliant. More than 1, just more than 1. So it can fall from 2 to 1, 3 to 1, 4 to 1, 5, 7, 8, 10, 20, 97, whatever. For Balmer series, come on, N1 will be 2, orbit number 2 is compulsory. From where? Any higher orbit than 2, 3, 4, 5, 6 and so on until infinity. Brilliant. And Paschen series, similarly, come on, Paschen series, we have to come on orbit number 3 from where? Obviously higher orbits, like, say, 4, 5, 6 and infinity. And then we have got bracket series. Bracket series will have to come directly where? To orbit number 4. From where? Higher orbits, 5, 6, 7, 8 and till infinity. And so on. Okay? I hope. Fund will likh lo. Fund series will be 5 from 6, 7, 8, 9 and till infinity. Whatever it is, like, say. But you're doing excellently good. Keep it up. Brilliant. Okay. Now there is one more terminology. Let's learn that also. Come on. So that terminology says, like, say, first line, also called alpha line. Then we have got second line, or say beta line. Then we have got third line, or you can say gamma line. And similarly, until last, this is called last line, or you can say limiting line. limiting line. Sometimes they give you limiting line. So people don't understand that stuff. It's very important we understand that. Like now for say first line for Lyman series, for Balmer series, for Bastian series, and so on. And so on. Chalo batao. For Lyman series, the first line or the alpha line will be formed when the electron falls from 2 to 1. First line will be from just 2 to 1, just above. Then 3 to 1, 4 to 1, and so on. And last will be infinity to 1. Good, very good, very good. And how about the Balmer line? The first line will be 3 to 2. The base line has to be 2. 4 to 2. 5 to 2. 6 to 2. And so on. And then finally, infinity to 2. Agree everyone or not? Now a very important thing, very important thing, that bachcho, these four lines are the visible lines, in the Balmer series. Are you getting? First four lines are the visible lines in hydrogen spectrum in Balmer series. Are you getting that? Only in hydrogen atom. If I change it to helium plus, lithium 2 plus, answer will change. Are you getting it? The first four lines, alpha, beta, gamma, delta, are the visible lines. Remaining are invisible. They all belong to UV region. All of them belong to what? UV region. Yes or no? And similarly, in Bastian series, we can write on Bastian over here. In the Bastian series, what will happen? First line, 4 to 3, 5 to 3, 6 to 3, and ultimately infinity to 3. Now, most of the questions you will be coming across, they will belong to Lyman, Balmer, and Bastian only. 90 to 95% questions will be from Lyman, Balmer, and Bastian. So, I mean, I'll suggest to you that you do it very properly. Good one. Very good. Very good. Okay. Chalo, aa jao. Done. Now see that stuff. Remember that one more thing. That when electron jumps, say for example, from N2 to N1, where N2 is more than N1, So when the electron will jump, I told you that it will emit a photon, which is nothing but electromagnetic radiation. And this electromagnetic radiation is a wave. And like any wave, this photon will have a wavelength and frequency. This will be given by delta E equal to h nu equal to hc upon lambda. So we have a one formula for that stuff, for hydrogen atom. Everything today I'm discussing is only for energy gap decrease, Nasser. Beta Kusuma, we'll discuss that in the Bohr's model. That Bohr's model we are not discussing today. That will come and we'll discuss in detail over there. Okay, don't worry at all. So I'm saying this photon, the lambda of this photon, which is also called like 1 upon lambda, is also called nu bar, wave number, is equal to r into z square 1 upon n1 square minus 1 upon n2 square. Remember that, where n2 is more than n1. This z is called atomic number. But this r is called Rydberg's constant. And for you people to learn the value is 1.09 into 10 to power of 7 meter inverse. Or you can say r value will be 1.09 into 10 to power of 5 centimeter inverse. And more than that, a very useful information, that value of 1 by r is actually 912 angstrom. Learn this, we'll be using in few questions this value directly. Okay, so rather than evading, that all that calculated things, we can use this value. Okay, yaad karo usko, just learn it. Good one, very good, extremely good. चलो आ जाओ. Now understand one thing, say again N1 and N2, and N2 is higher than N1, and if an electron falls, it will emit obviously electromagnetic radiation, a photon, and yes, we have the delta E equal to what? This is En2, this is En1, En2 minus En1. Okay, this delta E is equal to what? Energy of the given photon equal to hc upon lambda. Achha, from here, I mean, if I'm not wrong, let me know that delta E is proportional to frequency, is proportional to 1 upon lambda. Agree or not? And if that is the case, we all know that if I want delta E to be maximum, then frequency of the photon will also be maximum, which means what? That lambda of the photon will be minimum. If frequency is higher, lambda will be minimum. Agree, everyone? This is extremely important to handle certain questions. Okay? Okay. Now look. Like if you want delta E to be maximum, in Lyman series, electron should fall from where? If you want delta E to be maximum? Come on. Infinity. No. Durga Prasad. It should fall from infinity. Arre yaar, kaisi baatein kar rahe ho tum log? See, this is orbit number 1, this is orbit number 2, orbit number 3, orbit number 4, and so on, and this is orbit number infinity. So you can assume that these orbits as floor of a building. So tell me one thing, if you jump from orbit number 1 to 2 to 1, this energy will be more, or you jump from infinity to orbit number 1 or floor number 1, in which case you find the gap of energy is more. There has to be something called common sense. Where is the common sense, boys and girls? What are you doing, boys and girls? Yes or no? Everyone got it now or not? The greatest energy difference will be between orbit number infinity and this one. Yes or no? So I believe that this N2 has to be infinity. N2 has to be infinity. Acha, chalo batao. Now tell me one thing that for Lyman series, I mean, electron should fall from where to where? From where to where? Come on. From infinity to 1. In that case, delta E will be maximum. For Balmer series, electron should fall from where to where? If you want delta E to be maximum, electron should fall from where to where? Jaldi batao yaar. Come on. It will be from infinity to 2. If you really want a maximum energy difference, the electron should fall from where? Infinity to 2. Very good. Acha, one more thing. Similarly for Paston or any other line, infinity to 3. Yes or no? Very good. Acha, now one more thing. If I want delta E to be minimum, the energy of the photon to be minimum, I will like to have frequency minimum and also what? Lambda maximum. If the energy is minimum, lambda will be maximum. Now tell me one thing. Like that, what I should do? What should condition that delta E is minimum? Yes, the gap should be only 1 floor. You should jump just above the first floor. In case of Lyman series, very good. So in Lyman series, I mean, N2 minus N1 should be equal to 1. Agree or not? N2 minus N1 should be equal to 1. Alpha line. Very good, bache. It should be alpha line. Next orbit, just higher orbit. Very good, very good. Chalo, aa jao. See that stuff? So can I say for Lyman series? For Lyman series, like the electron should jump from what? N2 to N1, hai na? So that means 2 to 1, 2 to 1. And Balmer series, come on. Balmer series, it will be from 3 to 2. Am I correct? Am I correct? Very good. Okay, now similarly for Paston series. Similarly for Paston series, it will be from... No, bache, all of them are alpha line. All of them are alpha line. This is the alpha line of Lyman series, this is the alpha line of Balmer series. And this will be alpha line of Paston series, 4 to 3. First line anywhere is the alpha line. Second line in any series will be beta line. Got it all of you? All of you got it? Very good, very good, very good. Chalo, now see few questions now. First of all, okay, come on. Which transition of electron shows emission spectrum? Emission spectrum. Which transition shows emission spectrum? First, come on, 1 to 5. Second, 3 to 2. Third will be like say 4 to 7. And fourth I'm giving you, maybe say 2 to 8. Chalo, in which case you believe will show emission spectrum? Emission spectrum. Correct. Brilliant. I mean, electron should move from higher to lower orbit. Higher to lower orbit. Yes. That is the emission spectrum. And all of them will show you what? Absorption spectrum. Very good. So let's do some questions now. Chalo, question number 1 I'm giving you. Find lambda max and lambda min in Lyman series in hydrogen atom. Come on. Find lambda max and lambda min. Everyone, be quick. In Lyman series in hydrogen atom. Come on, I'll first find out lambda max. Now for lambda max, I need delta E should be what? Minimum. Delta E will be minimum when N2 minus N1 is equal to 1. That means the electron should jump from what? 2 to 1. Yes or no? In the Lyman series, it should jump from 2 to 1. Very good, bache. Very good. Now, I know one thing now. That 1 upon lambda will be equal to what? RZ square 1 upon N1 square minus 1 upon N2 square. Now, you all know that Z is 1. Z is 1 for hydrogen atom. Z is 1 for hydrogen atom. Yes or no, everyone? So can I say 1 upon 1 upon lambda is equal to R 1 upon N1 square minus 1 upon N2 square. And if that is the case, I can say that 1 upon lambda max should be equal to R 1 upon 1 minus 1 upon 2 square, 4. Can I say that? Oh, wow. Very good, Anwar. So you take the LCM beta now, and you better take before me. 1 upon lambda max will be R. This will be 4 minus 1, 3. 3 upon 4. And I believe that lambda max will be 4 by 3R. 4 by 3R. Be careful. 4 by 3R. How many of you got it? Anwar got it. Sindhu got it. Saranya. Ashirvadam. Shruti. Preeti. All of you got it correct. Very good. Ananya got it. Very good. Good. Very good. Acha, chalo now come to lambda minimum. Now to have lambda minimum, I believe delta E has to be maximum. Now delta E will be maximum when the electron falls from infinity to 1 in Lyman series. Infinity to 1. Can you calculate that stuff? The lambda minimum. So 1 upon lambda minimum will be R 1 upon 1 square minus 1 upon infinity. Now 1 upon infinity is 0. 1 upon infinity is 0. So 1 upon lambda min is equal to r, and that is it. So lambda min will be 1 by r. Will be 1 by r. Are you getting that, all of you? Very good. Will be equal to 1 by r. Now, they can also ask you one more question. Boys and girls, remember that this NEET, as far as chemistry is concerned, it is more about learning and understanding initially. If you learn little bit in the chemistry and understand it simultaneously, I mean, there is no stopping for you people. What I'm saying, in this part of atomic structure, the questions are almost fixed. Almost fixed. So I'll recommend, boys and girls, that you should be learning certain answers. See, 90% questions will be coming from Lyman and Balmer series only as far as hydrogen spectrum is concerned. I mean, if you're done with that, you will be doing very good. Your confidence will go up. Achha, when will your confidence go up? Go up when your marks go up. If your marks are coming down, there is no chance you can sustain the confidence level. It will take a plunge. It is 110% going to take a plunge. So I'll recommend that please learn certain things, revise them multiple times. You have a speed, you have anything now. So they can also ask you that find lambda max upon lambda min in the Lyman series. Lambda max upon lambda min. So you can do that stuff. 4 by 3r and 1 by r. So r cancels. This will be 4 by 3. It will be 4 by 3. Yes or no? Good. Good. Okay, here we go. Same question, but this time you have to find out lambda max and lambda min for Balmer series. For Balmer series in hydrogen atom. Be careful. All these questions we are doing today all belong to hydrogen atom. Okay? With respect to one electron species other than hydrogen atom. We'll do the question maybe later on. Okay? Come on, find it out. In 1 minute, both the answers I want from all of you. Everyone should be solving. Lambda max, lambda min for hydrogen atom, for Balmer series. Venkat Reddy beta, find the answer for lambda max, lambda min, the values. We got someone? No. I want value of lambda. I don't want orbit transition. That you must be knowing that. Anwar, correct again as usual. Ashirvadam, correct beta. Correct. Lachanna, ठीक है. Shrinu, very good. Preeti, good. Madhu, very good. Sindhu, very good. Sharanya, arey wow, very good. Arey wow. I mean, everyone is giving right answer right now. Very good. Excellently good. Brilliantly good. भैया बहुत अच्छा कर रहे हो यार. Doing very good. Come on. So, lambda max. Acha, find out lambda min now. Find out lambda min. All of you. Find out lambda min right now. Or if someone got, okay. We have got Kanti Srinivas, very good. Manish, very good. Anwar, good again. Ashirvadam, very good. Niharika, good. Devasani, very good. Everyone, Madhu, Ananya, Shruti, everyone getting the correct answer. Jyotsna, Achna, Akhil Varan, Arun Raj, Preeti. Kya answer hai? Very good batch. I mean, the number of responses I'm getting is unbelievable. Almost everyone is answering. Almost everyone. Very good. Superb. अबे इतना अच्छा response तो मुझे physical class में नहीं मिलता जितना तुम मुझे दे रहे हो यार बच्चों. Hats off to you people. Keep it up. So lambda max, I know that I'll get when delta E is minimum, and delta E will be minimum when in Balmer series electron moves from 3 to 2. Energy difference will minimum when it jumps from just above orbit, है? Okay, now so 1 upon lambda max will be r 1 upon n1 square 4 minus 1 upon 9 3 square. Okay, so 1 upon lambda max I believe will be r. This will be 5. 9 minus 4 will be 5 upon 36. So I can say lambda max will be 36 by 5R. 36 by 5R. 36 by 5R. Very good. Very good. Lambda min. Now to have lambda min, I need delta E to be maximum. And I know that will come when the electron falls from orbit number infinity to orbit number 2 in Balmer series. So 1 upon lambda min will be 1R. Now 1 upon 4 minus 1 upon infinity. And 1 upon lambda min here will be R by 4. This will be 0. This will be 0. So lambda min will be 4 by R. Will be 4 by R. Agree or not? Now again, a similar kind of question like find lambda max upon lambda min. They can ask you anything. So if you remember these values, you will be very fast. Come on. Lambda max 36 by 5R. Upon what? 4 by R. So R and R gone. This will be 9. Will be 9 by 5. Wow, very good. Durga Prasad, very good. Preeti, Madhu, Hero Zuli, Hero Zui, क्या नाम है यार? Lachanna, very good. Sai Krishna, simplify that. Sai Krishna, simplify that. Sunitha, Shruti, very good. Everyone. Venkat Reddy, Ashirvadam, Anwar, Sindhu, Sahiti, Sindhu, Keshavaraj, Kushma Kumari. Okay, very good, very good. Okay. Now, I mean, since you have done all that, lambda max, lambda min, and you have done for Balmer series, Lyman series also, so I'm asking you right now, find lambda max of Lyman series upon lambda max of Balmer series. Come on, will be equal to how much? Come on, lambda max of Lyman. You have done it. You have done it already. Lambda max of Lyman is 4 by 3R. Is 4 by 3R. And lambda max of Balmer, come on. Lambda max of Balmer, 36 by 5R. 36 by 5R. R cancels 4, 9. And this will be 5 upon 9 3s are 27. 5 by 27. Yes or no? Good. Durga Prasad. Wow. Very good. Manish, very good. Anwar, Sanam, Kusuma, very good, very good. So these kind of questions, they are like a ready-made question, specifically prepare Lyman and Balmer questions like anything, like a pro. You will not regret, and I'll teach you certain more tricks in the coming lecture when we'll do that Bohr's model, that how to get these answers as soon as possible, as quickly as possible. Okay. Okay, now come over here. Come. Okay, now come. Acha, now see, I told you that electron can jump. I mean, this is a nucleus. Electron can jump from anywhere to anywhere. It can jump like say here. It can come in like say multiple jumps. Are you getting it? It can come directly. It can take like say 2 jumps, maybe this one and then direct jump. So any kind of possibilities there. Yes or no? So while coming down, they'll form lines. Like this is 1 line, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. Yes or no? So when the electron jumps, please write down total lines formed when electron jumps from N2 to N1. From N2 to N1. N2 obviously N2 will be more than N1. So over here, total lines will be equal to N2 minus N1. N2 minus N1 plus 1. Derivation is not important here. The formula is upon 2. Upon 2. Okay, we'll do some questions on that to get the mastery over it. Now, there is one more thing that generally, like if electron jumps from orbit number n to orbit number 1, then total lines formed will be n into n minus 1 upon 2. You put n2 equal to n and n1 equal to 1, you will get this formula. Remember these two formulas, they are very, very important. These are total number of lines formed. Total number of lines formed, okay? Very good. Very good. Okay, now see very quickly. So these are total number of lines formed. So what I'm saying, that electron jumps from n to orbit number 1, number of Lyman lines will be equal to what? N minus 1. Please learn it. N minus 1. Number of Balmer lines will be n minus 2. Just one line less than the Lyman lines. Number of Paschen lines, come on, will be n minus 3. Number of bracket lines will be n minus 4. Very good. And number of fund lines will be n minus 5, and so on. Each line will be just one less. Just one less. So let me ask you one question. For example, number of Lyman lines formed are like, say, 10. Then number of Balmer lines will be how many? Number of Lyman lines are 10. Number of Balmer lines will be how many? 9. Very good. Okay. Number of Paschen lines will be? Number of Paschen lines? 8. It will be 8. Very good. Chalo, let's do question. So I'm saying that electron jumps from, like, say, 6 to orbit number 1. Total lines formed. Chalo, come on, find out total lines formed. Everyone, the electron is jumping from orbit number 6 to orbit number 1. Find out the total number of lines formed. 6 to 1. Come on. So I believe that when electron jumps to orbit number 1, it will be n into n minus 1 upon 2 will be 6 into 5 upon 2 will be equal to what? 15? Everyone? Wow, superb, brilliant. Kya baat hai? Excellently good. Superb. Now in the same question, come on, tell me number of Lyman lines. Who will tell me number of Lyman lines? Come on. Number of Lyman lines. Ananya, very good. No, Srinu, no. Sahiti, very good. Gaming, very good. No. Not 14. It will be 5. So orbit number n is what? 6. So n minus 1. Out of these 15 total lines, 6 minus 1. 5 will be Lyman lines. Number of Balmer lines, come on, will be n minus 2 equal to 6 minus 2 equal to what? 4. 4 will be Balmer lines. And number of Paschen lines, come on, n minus 3 equal to 6 minus 3 equal to what? 3. And similarly, number of bracket lines will be how much? 2. Keep on decreasing by 1. And number of fund lines will be equal to what? 1. When you will do total 5 plus 4 plus 3 plus 2 plus 1, it will be 15. Total lines are 15. Out of those 15 lines, Lyman lines are 5, Balmer are 4, and Paschen 3, and keep on decreasing by 1. Total becomes 15. Yes or no? Every Okay. चलो एक और क्वेश्चन करेंगे. One more question. Come on. Electron jumps from 8 to 3. Orbit number 8 to 3. Find total number of lines formed. Come on, everyone. Total number of lines formed. Come on. Total number of lines formed this time will be 8 minus 3 into 8 minus 3 plus 1 upon 2. Come on. Gaming, very good, bache. Very good. Keshav Raj, no. Sriram, no. Total number of lines formed 15. This will be 5 into 6 upon 2 equal to 15 again. Total number of lines formed will be 15 again. Please check, everyone. Venkat Reddy, please check again. 15. And now number of Lyman lines number of Lyman lines will be how many? Come on. Number of Lyman lines. Who will tell me? Number of Lyman lines. It was a googly. It was a googly. It was a googly. Zero. Zero lines will be formed in Lyman series. Zero. How come? Lyman lines are formed only when electron jumps to orbit number 1. This question restricts the movement of electron to 3 only. Electron is not allowed to come to orbit number 1. Ananya, electron is not allowed to come at orbit number 1. It can only form Lyman when it comes to orbit number 1. Yes or no? Chalo. And you people don't play googly very well. Okay, chalo batao. Number of Balmer series or Balmer lines. Number of Balmer lines now. Come on. Now correct. Now correct. It will also be 0. Because to form Balmer lines, we need to come to orbit number 2. This question restricts us at orbit number 3 only. 0 again. Chalo now. Number of Paschen lines. Number of Paschen lines. Come on. Everyone. Now it will be 8 minus 3 will be 5. And number of bracket lines. Number of bracket lines. Come on. It will be just one less. 4. And fund lines. Fund lines. 3. And then whatever. 2, 1. Total will become 15. Total lines will be 15 only. Total lines are 15. Remember that. But and every line will be like downward, one less. One less. Okay? Okay. Now one last thing remaining. One last question we'll do. You can see that good here. Everyone out here. I'm saying that electron jumps from orbit number n to orbit number 1 and total lines formed are say 10. Total lines formed are say 10. Find the value of n. Find the value of n. Come on. Come on. I'll share a good trick with you people. Okay. I will see or what? Niharika has given answer. Gaming has given an answer. Deepthi has given an answer. See, I'll share a trick with you people. I know that total number of lines formed is what? Total number of lines formed is n into n minus 1 upon 2. This is given as 10. So n into n minus 1 is equal to 20. Agree or not? Now your job is basically that to find out the factor of 20 in such a way that the factors are having a difference of 1 only. This number n and n minus 1 have a difference of only one number. So can you find out two factors? Two factors of 20 with difference of 1? I believe 5 into 4. 5 into 4. Very good. So 5 into 4 is equal to 20. Your answer will be like what? Bigger number. If you compare these two, n will be 5, n minus 1 is 4. There is no need to do any quadratic equation. So your n will be 5. Electrons will jump from orbit number 5. Yes or no? Okay. Similarly, electron jumps from n to 1 and total number of lines formed is say 21. They're saying find n. Come on, be quick. I believe again, total lines formed will be n into n minus 1 upon 2 equal to 21. N into n minus 1 will be 42. Find out the factors of 42 such that the difference is 1. I believe 7 into 6 will be 42. So bigger number is n. So n will be equal to 7. N will be equal to 7. Getting it? Very good. Can I ask you last question? Last question for the sake of practice. For the fastest fingers first. Fastest fingers first and then we leave it. Come on, and I want everyone to be right. N to 1, total number of lines is 36. Find N. Come on, find N. Be quick. Come on, find N. Oh, brilliant, Ananya. Very good. Manish, very good. Shavanika, very good. Wow, very good. So I know that n into n minus 1 upon 2 will be 36. So n into n minus 1 is 72. Factors of 72. 9 into 8 is 72. Bigger number is our answer. N will be 9. Getting it, everyone? Your performance today was outstanding. Brilliant performance. I'm supremely happy. Thank you, boys and girls. Thank you very much. God bless you all. That will be all for today. I'll catch you later on. Bye-bye. Bye-bye. All the best. Bye-bye.